All right, everyone, welcome to online version of section 9.4. This is a two-sample means test. And for a two-sample means test, we're going to talk about a couple different things, and we're going to go over the calculator portion. So the test of significance for two unknown means and an unknown population standard deviation. There's the whole reason why we're using a t-test. So the degrees of freedom for two samples can be either conservative or calculator degrees of freedom given after running the test. So for conservative being the smaller of the two sample sizes minus one, or you're going to use the calculator. And the main thing is that you are going to be using the calculator version of the degrees of freedom, and you're going to do this after running the entire test. So that is the biggest thing about this first page. So just like before, your null hypothesis, you're going to have mu sub 1 equal to mu sub 2, which another way that you could say this is mu sub 1 minus mu sub 2 equals 0. And then for the alternative hypothesis, you're either saying that they're not equal to each other, one is bigger or one is smaller. And then when you subtract the two of them, obviously then it's either not equal to 0, smaller than 0, or bigger than 0. But the main thing is over here. The calculator portion, you're going to be doing stat test 4 because we're going to be doing a two-sample t-test. And the main thing that you need to highlight and double check and triple check is that you are making sure that whenever you do this in your calculator, you are highlighting no for the pooled. And that is basically saying that you are letting your calculator come up with the degree of freedom. So after running the test, so you only need to pool for a two sample proportion test. The two sample means t statistic, again, it's something that's very similar to what we were doing before, but we've got x bar sub 1 minus x bar sub 2, and then it's minus. This portion will always be 0, and then all divided by the first sample standard deviation squared over the first number of samples, and then plus the second standard deviation squared divided by the second number in the sample. And it's the square root of both of those combined. So just a quick note that the AP exam common error, many students use their calculators to conduct a two-sample t-test, which we will do. Also, writing out the equation using the conservative degrees of freedom. This is dangerous because these methods will not produce the same answer. So back up here to the top, there are two ways of getting the degree of freedom for a two-sample t-test, but they will get you different answers. So when you write the degree of freedom, you're going to leave it blank until you run the test, which if you are watching this video and your friend is not, please warn them that I said that you need to leave your degree of freedom blank until you run the test in your calculator. That is going to be huge going through this portion. So as we go to our first example, keep in mind that these are going to be a two-sample test. So we've got within a school district, students were randomly assigned to one of two math teachers, Mrs. Smith and Mrs. Jones. After the assignment, Mrs. Smith had 32 students and Mrs. Jones had 30. At the end of the year, each class took the same standardized test. Mrs. Smith's students had an average score of 78 with a standard deviation of 10, and Mrs. Jones's students had an average test score of 85 with a standard deviation of 15. We're going to test the hypothesis that Mrs. Smith and Mrs. Jones are equally effective teachers. Use a 0.1 level of significance. So the main thing is go ahead and go through figuring out who goes with which number, and then it's easiest if you write them out. So what we're doing is conducting a two-sample hypothesis t-test because our standard deviation for the population is not given. So we can go ahead and start by writing out the null hypothesis. So we would originally say that mu sub s is equal to mu sub j. And then the alternative, if we're trying to see if they are both equally effective teachers, that would mean that the alternative would be that they are not equally effective. And then be sure to write out what each of your labels represent. Keep in mind that as you write out your mu sub s and mu sub j, your labels for each, that you're using the true population mean for both of these. After that, we can go ahead and label exactly what we are talking about. We are doing a 2-sample means t-test with a degree of freedom of some number that we're going to put in later on, and our alpha level is 0.1. You have to write out this every single time that you do it, and you will also be scored on that on the AP exam. After that, you're going to go through random. Your standard deviation is unknown for both teachers, so you're writing down the population standard deviation. Standard sampling distribution is approximately normal, and then independence. Please make sure that you have paused this recording to go ahead and check everything that you have written for the 2-sample means conditions for the t-test. Now, as you'll see that when I was trying to figure out if the sampling distribution was approximately normal, I used the central limit theorem that says that n is greater than or equal to 30. And then the last thing was testing for independence. You could test the population greater than or equal to 10n. But then I was also able to say, because this is an experiment, the student test scores are independent. So you can go ahead and do either one. After that, we're going to go ahead and draw a picture, write down our formula, use our calculator, and then write our conclusion. So when we go ahead and draw our picture, we've got 0 going in the center. Now you're going to take your x bar sub s minus your x bar sub j, because as we went up to the top, if I were to solve this right here, if I were to move that u sub j to the other side, it'd be mu sub s minus mu sub j. So I just went in the same order right here, but we don't obviously have mu, we have x bar. So when you take your two numbers, 78 and 85, and subtract them, 78 minus 85, you're going to get -7. So I'm going to go ahead and put that right there, and then shade that way. But obviously you can go, because it's not equal to, we have to go on both sides shading wise. After that, we've got our t-statistic formula. So you've got x bar sub s minus x bar sub j minus mu sub s minus mu sub j, all over the square root of the sample standard deviation over the number in the sample. Next up, you have your numbers. So you've got -7 minus 0 divided by the square root of 10 squared over 32 plus 15 squared over 30. And then from there, what we're going to do is use our calculator. So in your calculator, you're going to go stat over to test and then down to number 4. It's a 2-sample t-test. Make sure that you have stats highlighted. Notice that the first thing that it has is x bar sub 1. So you need to make sure that you are typing in Mrs. Smith's average. So her average goes first, then her standard deviation, and then the number of students that she has. And same thing then for Jones. You've got, again, the average, then the standard deviation, and then the total. Make sure that you have not equal to highlighted, which was the alternative hypothesis, and then that was the important part, is the pooled part. You need to make sure that that has no, and then you can go ahead and calculate. You can see right here that we have our t-statistic, it's -2.15, our p-value 0.0366, and then right there is the degree of freedom. So you can go ahead and at the very top of your page, for your 2-sample means t-test with degree of freedom, we can go ahead and put in 50.1. And then that is all the information that we need for this. And we can go ahead and then write our conclusion. Because the p-value of 0.0366 is less than the alpha, we're going to reject the null hypothesis, and then we can go ahead and put our evidence to suggest, and then actually state what it shows. So this would show that there is evidence that Mrs. Smith and Mrs. Jones may not be equally effective teachers. So go ahead and write that all out. I'm going to go ahead and pause the video for you guys, and you're going to see all the answers on the screen. And there you have it, the full conclusion of this two-sample means t-test. For the last example, there's only about 4 minutes and 30 seconds left of this recording. So we've got a company that's developed a new battery, and the engineer in charge claims that the new battery will operate continuously longer than the old battery. Now, to test the claim, the company selects simply random sample of 100 new batteries and 100 old batteries. Then it goes on to say that the mean and the standard deviation for each one. And then what's key is that both samples come from a population that is known to be normally distributed. So we're going to go ahead and use that when we have our conditions. To start with, we are going to test the engineer's claim that the new batteries run longer than the old, using a 0.05 level of significance. So we can go ahead and come up with our null hypothesis, where these are equal to each other. I'll use 1 and 2. I'll say that 1 is the new battery and 2 is the old battery, which I will label in a second. Now, what we're doing is we're testing the engineer's claim that the new batteries run longer than the old. So that would mean that this is better than that one. I'm going to go ahead and write out what each one means. Keep in mind that when you are writing these out, another way to say that right there is mu sub 1 minus mu sub 2 is equal to 0. And then this way, another way to write it is mu sub 1 minus mu sub 2 is greater than 0. So just keep in mind that as you go through these processes. So we're going to go ahead and put our title and then our conditions. Do not forget to fill in that degree of freedom after you run the entire test in your calculator. Now, because the original paragraph did say that the population is known to be normally distributed, that was key for our bullet point right here. Now, you do need to say, I'm going to add it in right here, that this is unknown. Afterwards, we can go ahead and draw our picture, write our formula, and then start typing things into our calculator. So at this point, we have our information. We went ahead and shaded. I did my new battery minus my old battery mean, which is 10, shaded greater than that. It goes back to the alternative hypothesis. Next step, we're up for the calculator portion. So you're going to go into stat, go over to test, and then we are on a two-sample t-test. You need to make sure your stats are highlighted. You have your new batteries mean, new battery standard deviation, and then your new battery numbers, the amount of new batteries that we have, and then the same thing for your old batteries. Make sure that you have no for your pooled, and then we go ahead and highlight your mu sub 1. We have the same direction as your alternative hypothesis. Go ahead and calculate. You've got your t-stat, your p-value, and then don't forget to fill in your degree of freedom, 145.6 at the top up here, 145.6. Go ahead and put all of your numbers down and then write your conclusion. So based on our data, we can conclude that new batteries seem to have a longer runtime than old batteries.